In this video, we're going to talk about correlation. Now, correlation, as you might have heard, is a relationship test. It's where we examine whether variables are related or not. Now, in this video, we're going to talk about what correlation is. We'll talk about what the qualities of a correlation are that are important. And then we'll also talk about the difference between this idea of correlation and causation, because we know that correlation doesn't equal causation. Now, stick around to the end so we can give you some testing strategies too. Hey, it's Dr. Pamela Kreiser here at the Research Methods Crash Lab. We're here not only to help you survive your methods class, but we're here to help you thrive. Now, if you hate math, you've come to the right place, because here at the Crash Lab, we're ready to help everybody. Let's head into the lab. A correlation is a relationship test. When a researcher is running this type of quantitative test, the researcher is testing whether these two variables are related. Now, there are four possible outcomes in correlation: a positive correlation, a negative correlation, a nonlinear correlation, or no correlation. But let's keep it simple and talk about linear correlations. Let's say a researcher was interested in whether the following two variables were correlated or co-related. Let's say you were looking at height and weight. Now, in looking at these variables, the researcher might be confident that these two variables are positively and significantly correlated. What does that mean? When something is positively correlated, it means that when one of the variables goes up, the other goes up as well. Now, in this example, height and weight are positively correlated. When height goes up, weight goes up. And when height goes down, weight goes down. In other words, they move together. In a different example, we can examine the following variables: speed and travel time. And this will illustrate a negative correlation. When something's negatively correlated, it means that when one variable goes up, the other variable goes down, and vice versa. In this example, speed and travel are negatively correlated. So when speed increases, travel time decreases. And when speed decreases, travel time increases. In other words, they move inversely, or in the opposite direction in relationship to each other. Now, in some cases, we find that variables are unrelated. This means that the researcher can find no significant relationship between the two variables. Take the example of height and intelligence. A researcher might analyze height and intelligence to see if they are correlated. However, if the researcher finds the association is not significant, which means not strong enough, we consider it to have no relationship and is not correlated. Determining significance comes down to running the numbers or calculations, and in most cases, this is done using a statistical program on the computer. One way to think about correlations is to focus on strength and direction. When we talk about strength, we're testing whether the mathematical relationship is strong enough to be considered a significant relationship. Mathematically, correlations range from -1 to +1. The closer your correlation number is to 1 or to -1, the stronger your correlation. The closer your correlation number is to 0, the weaker the correlation is. One way to think about strength is that a correlation closer to +1 is closer to a 100% positive relationship, and a correlation closer to -1 is closer to a 100% negative relationship. Now let's talk about direction. When we talk about direction, we're commenting on the type of relationship between these two variables, whether the variables have a positive correlation, a negative correlation, or no relationship. This is indicated by the valence sign, the plus or minus sign. Keep in mind that the number represents the strength of the correlation, and the sign represents the direction. One way to understand strength and direction is to look at a graph of the data. The first example is a strong positive relationship. Let's say you were examining the relationship between minutes of exercise and endurance levels. On the x-axis, we are plotting minutes of exercise, and on the y-axis, we are plotting endurance levels. Now here we can see a positive correlation. We can examine the linear correlation line of best fit. We observe that it slants up and to the right. This shows the trend of the two variables, minutes of exercise and endurance levels, being positively correlated. The strength of the correlation is represented by how close these scores are to the line. So a strong positive correlation looks like this. A weak positive correlation looks like this. So you can see how close the data points are to the line indicates how strong the correlation is. In the second example, we examine a strong negative relationship. Let's say you are examining the relationship between public speaking anxiety and confidence. On the x-axis, we are plotting public speaking anxiety, And on the y-axis, we're plotting confidence. So we take each person's score on both variables in our sample and record it on the graph. Here we can see a clear negative correlation. We can examine the linear correlation by inserting a line of best fit. We observe that it slants up and to the left. This shows the trend of the two variables in public speaking anxiety and confidence being negatively correlated. Again, the strength of the correlation is represented by how close these scores are to the line. A strong negative correlation looks like this. A weak negative correlation looks like this. Finally, if we had two variables that were not correlated, we might find that no line of best fit exists, and the scores would be scattered all over the graph. Like in the earlier example, we see that height and intelligence are not correlated. Our last topic is that correlation doesn't equal causation. In our specific example, we believe that public speaking anxiety and confidence are negatively related, but there are no identified causes. We don't know that lower public speaking anxiety makes one more confident, or that more confidence leads to less public speaking anxiety. We only know that they tend to move in the opposite direction. So we predict they're negatively related or negatively correlated. This means that when one variable goes up, the other goes down, and vice versa. When one goes down, the other tends to go up. In this example, we can only explain how the variables are or are not related to each other, and that is why we call this type of inquiry a relationship test. Now, earlier in this video, we promised to give you a strategy to help you improve your test scores. So you ready to take the next step? You can access our Quiz Me videos using the link here and test your knowledge. Well, thanks for watching. And if you like what you saw, make sure you hit that like button down below, and we'll see you in the next one.